Hey everyone, it's me, Obson. Okay, let's talk about what we're going to try to do here. Going to be talking about how to potentially move the words from an inflammatory part of the space into a less inflammatory place. So we've got I'm getting set up with a lexicon of inflammatory good and bad words using the Vader sentiment analysis. So let's see if I've got that. Here we go. Let's see. This would be, we'll call that lexicon. This is from Sentiment Intensity Analyzer from Vader Sentiment, the package. Let me show you the install for that. You want to pip install Vader Sentiment. That's in addition to the NLPIA package. If you've already installed NLPIA, you'll be good to go with pretty much everything we do here. And you don't really need this Vader Sentiment Analyzer. We're not going to actually use it as a package. We're just going to grab its lexicon of good and bad words so we can use those in a list of words that we can find that are on the opposite side of the world from the kinds of inflammatory texts that we're going to be trying to process. So I was just talking about getting the lexicon of good and bad words. If someone would like to go out on the web and find some inflammatory text for us to parse with, and I need to import spacey as well. I'm going to use that even though we're not going to use the word vectors in it. Let's do it from query. So we'll make sure we've got a decent tokenizer. Spacey, the word spacey stands for space because there are spaces between words in most cases. Spacey is a pretty fast and good tokenizer. Also does great. I'll increase the microphone volume gain just a little bit. Make sure the echo doesn't come back. And I don't know if there's a Discord channel that Manning has set up. I don't see it in these links yet. Stream Elements, if you could post that for us if there is one. Don't need it. We can just use the chat here. But if someone could go out on the web and find some inflammatory title or sensational headline or clickbait advertisement that we can work with, something that has some positive and some negative words in it that we can turn positive. So I'll give you some examples of some of those words that we're going to be working with in our lexicon. We'll give you the bad words. Let's look at the 20 worst words in our lexicon. So words along these lines about villains and evil, and those are even pretty much worse than I was hoping for. We could even go for something heartbroken. Those kinds of words. If you find some of those inflammatory, scary words out there in the world, you can post them here in the chat, and I'll process those as text. So let's say that let's try something simple, something mild. I'm feeling sad today. And then we will try to find the negative words, and then we'll try to replace them. So this is going to create what's called a document in Spacey. Spacey has, and this has a vector built into it. It's the average of all the word vectors that are there. We don't need that one. We've got also from we've got a word vector object that is from the NLPIA package, which is what this talk is all about, the Natural Language Processing and Action book. So that we've imported earlier, we imported, from the loaders, we imported get data. And then let's just go ahead and do that just so you can see how that's done. And then we'll say word vector equals get data. And you can say word2vec, or you can spell out word2vec, and that will get all the word2vecs. The reason I like this a little better is it gives me a straightforward way to find individual words and to do similarity between individual words and do word analogy problems. That'll come in handy later. Also, it takes a little bit of time to load though. You want to make sure you have lots of RAM. Let's make sure we're still doing okay. Oops, got a lot of RAM usage now. May have to close some windows here. Let's close my Gmail. That's not typically a good one to, that didn't help much. So it's probably because I've loaded the spacey language model. I'm right up at the top of what I can handle here. So I may have to look around. Anyway, we'll see how it goes. If I have to reboot, we'll reboot. So you want to, we'll just only load, we won't load any more language models. So I've loaded 2 large language models. As you can see in this word vector object that we loaded, it has an attribute called vocab, which contains all the words. So we've got, it looks like 3 million words in here. Spacey language model, the medium one, I think is the one I loaded. Let's see what its vocab looks like. I think it's like 20,000 for the medium. Oh no, that's right. But it does a clever thing where it only actually compresses it down to 20,000 word vectors. That's why I'm using the bigger one from word2vec. It has a lot of words that map to a combination of those smaller number of vectors. But anyway, we're going to be working with the more straightforward one, word vector, where there's a one-to-one correspondence between words and vectors. And we can look them up in word vector. Like, let's look up that word sad. First, let's just see if we can come up with a good word that's the opposite of sad. That's more closer to the other end of, that's the word vector. And now we can also, within that package, we can look for most similar, I think is what we're looking for. And we can give it, I think we have to give it a word. Yeah. Of course, we don't want to actually find words similar to sad, but but we will see. Ooh, and we don't want most similar. And we just had a crash because I got too much loaded. Let's see how our RAM is doing. Okay, we're back down to 2 gigabytes. And now I will not load spacey. Maybe I'll load a simpler tokenizer like NLTKs. So let's go back and start from the beginning. From NLPIA data loaders import get data word vector equals get data word2vec. Okay, it'll take a few seconds. Then what we're going to do after that is we'll try to remember what the syntax was. I think I can look through the history of my previous. I'm going to open up another tab, make sure, see how this is going, see how much of the RAM is being taken just by the word vectors. Those 3 million word vectors would take up quite a bit. Looks like it's almost done. Took a couple gigabytes, 3 gigabytes. Yeah, maybe that was the bad boy that was taking up so much space. Let's look back at our history. Let's work on query to get into that conda environment. And now let's bring up another IPython so I can look at the history. And let's look back for similar. Let's look back for other things. Most similar. If you give it a list of words, both positive and negative, it will find some words for you. You can do some math within word2vec. I can also show you how to, I'm going to also show you how to do that manually with the vectors themselves. Now there's the Discord link. Let's get that going, just in case people over there instead of the Manning channel chat. Okay, now, so let's go back and see if word vectors have loaded. Great. Now let's do the most similar to, let's try that sad word again. We need to reload the sentiment analyzer. Let's see how big that one is. From Vader, let's see, let's try to find that. That was sentiment analyze. There it is. Let's look for that further back so we can find the import. There it is. So that's from Vader's sentiment, Vader.sentiment import sentiment intensity analyzer. Now we can create one, and now we can look at that lexicon. We need to import pandas. We'll also be using a lot of NumPy, so let's get that one in. Next, let's take a look at that. Let's turn that lexicon into a pandas series. It'll be easier to work with, and we can sort values based on the sentiment, whether it's positive or negative. And that's also, well, we'll just leave the full thing there, and we'll just slice it. Let's create our own lexicon object, which is that series, lexicon. And let's look for some words. Let's see where sad is in there first. .loc, let's look for sad, just to see what its sentiment is. Negative 2.7, so it's going to be pretty far up the list. But we're going to look for words on the opposite side, so let's look at those positive ones. And then we'll be good to, let's see, let's look at negative, let's top 30. How about that? Positives words. Joyous, Lyle. Maybe that's some synonym for laugh out loud I'm not familiar with. Love, happiest, best. Good words. Okay, now let's talk about doing some okay, let's look at that sentence we had before. Let's just call it sentence. I'm feeling bad today. We'll use bad instead of sad. And then see if we can turn bad to good. So we'll say, we're gonna, and actually let's make it even easier so we don't even have to import any kind of tokenizer. Let's just put some spaces where we want. And so we'll make a doc that's just the sentence dot split. So now we've got a doc which has each individual word or token, and we can look those up in Word2Vec. So we could also do sentiment analysis on that. Let's see, what do we want to do? We want to find that that bad word. So let's see if we can, let's make a list of good words out of this glorious set of words on the top 20. Let's make it a little bit smaller. Maybe we'll skip every third word perhaps. Nope, that's not the way you skip. I think that's the way you skip. Great. Those look pretty good. Let's we'll put those into a list, and we'll make some word vectors out of them. So good vectors. And that's going to be, let's make it into a, no, well, we don't need to do that yet. Let's, it's just going to be the word, the token, for token in lexicon, but we want to take the word vector for that. This could fail if those words don't exist. So give us, yep, I'm going through the values, not the, it's not the index. Let's see if I can do the index this way. Vectors. vectors. Let's look at the words, actually good words first, make sure that didn't. Let's make sure that that's doing what I want. So because those vectors are kind of invisible to me at the moment. Let's see what those words actually are. Okay, good. We're on the right track. Now let's see if we can find. I was working on a function to see the most similar word. It had some bugs in it. Let's just do it to a single word first. Let's look back at all the ways we can do similarity with word2vec. Most similar by vectors. That's the one that worked for me well before. Let's try that. I've named it differently though. We call it WV. And we're gonna say similar by vector. So we need to give it a word vector. Let's find some words similar to bad. And then we'll find words similar to some of the other words. And let's see what this returns. This returns a 2-tuple, so we can put that straight into a series. We can do it first, pd.series, and then we can say, we want to make a dictionary out of that first, and then make a series out of it, just like we did for our lexicon. And that looks like it contains the bad as the first word, so we probably want to take that out. We don't need, actually, let's just leave it like it is for now and see what happens. These are going to be the words that we're going to be looking for in our text. So this is going to be another set of words that we're going to include in it. So we can say bad words equals dot index. We could also have used that straight from our other lexicon. Let's see, bad words. Okay. No. Oh, interesting good is in there. That's no good. I'm going to have to stick with the Vader sentiment analyzer because those words have similar sentiment. They are kind of talking about the quality of something. So word vectors don't have the dimensions that you might expect always incorporated into them. This isn't going to make it challenging, but I think we'll do just fine if we just use sentiment analyzer.lexicon, and we'll just keep those a bit hidden. We'll take the first, like we did before, we'll take 30. What did we do before? Oh, we did, yeah, that's right. We want to do the first 30 words. Oh, that's skipping 30, I think. I want to do 30 there. Let's see how that works. Lexicon. Let's see what lexicon is. Oh, we have it in our other lexicon. That's why. Because that's the one that's sorted. No, nobody chatting over on the, let's see what we've got going on here. Nothing much going on either chat channel, so we're still just gonna open loop this. Ooh, got the values instead of the index. Good catch. Okay, let's go with let's start with, so we have some bad words and we have some good words. Next, we need to go through our sentence. We have a document, I think. Let's go for word in doc. We were looking at that most similar. We wanted to do a quick demo of the most similar. Similar by vector, that's what it was. So it was word vector, similar. Come on, give me a tab completion here. Help me out. Similar by vector. Oh, we can do it by word. Similar by word. And we can use that word bad. And we can use the word today. Let's see. And now let's see which ones are similar to, let's see if this takes 2 arguments or only 1. That's right, I'm using this for the output after the math. So after we've added it, I'm going to use this to find some words. But this is going to be the last step. What we need is a way to perturb a word to make it better. So let's take the word vector for bad, and let's add the word vector from the last list of our lexicon, good words, and let's do that. Let's pick one word from there. Or we could find, actually we could try to find the closest word to that one, I think. But let's see what we do. That's right, I was working on that function. So I need to go through that list of similarity. Let's see if there's a similarity. There we go. And let's see what it takes as arguments. Looks like it'll take words. Let's try similarity between good and bad. Sounds good. I think that's what it showed earlier. Yeah, 0.719, 0.719. Cool. So now we can just do that between good and or bad, and a list of words. Let's see if it'll do that. Probably not. So we will have to do it ourselves. And let's give it our lexicon of our good word vector. We can just give it the words themselves. Good words. Okay. Let's see what's going on here. Let's see what those good words are. And we're looking for the words that are similar to bad among those, and there aren't any. That's good because we have a lot of low scores. So now let's take that word vector for good. Let's make sure we can use a vector in this function first. I think we're getting somewhere. Let's get this one here. Let's see if it'll take a word vector in addition to the actual string. Nope, it won't. Similarly by vector, probably. Ooh, this might be handier in the future. For now, we'll just stick with using the words. Okay, now what I was going to do, though, I need to perturb that and find the most similar. So let's say the word vector, most similar. Make sure that's a thing. Yep. Positive. Make sure that's a thing. It is. Now we're going to give it some positive words, and we're going to say we're going to add some goodness, or we'll just add a whole lexicon of good words. And the negative. Let's see, we're trying to we need to also add to that the word that we're actually trying to perturb. So we're going to add a bunch of good words to the bad word that we found in our sentence, and then we're going to subtract off some badness, perhaps. List bad words, and then we'll see what comes out as the most similar word to all this. Can only concatenate list, not stir. Of course. See if anybody's chatting to me to try to help me avoid these bugs. Let's see. So we got, they're not very close, but we do find some words that are, once we add a bunch of good to that vector, that bad vector, they're pretty far away, all these other words, but so most of these words would do okay in terms of substituting for bad in that sentence. So let's just take the top one from that list and let's see what happens. So we'll just replace this with whatever word it is that we're trying to deal with. And we'll go through our list of, let's make this a for loop. Make this a little, so we can do a couple things inside of here. Start. I wonder if I can create a carriage return in between this. Let's say for w in doc, I think we called it. Yep. And see if I can do a control enter. Nope, it won't. Let's do, if I can do a shift enter maybe. It's just not going to help me out at all. I'm going to have to just do it by hand. See if I'll just copy paste. Fun, fun, fun. Okay, now we can change that to W. And now we can do something with that list. But first we want to make sure that it's not too similar to, and that similarity calculation, if I remember correctly, it takes a word. So we're going to check the if similarity yeah, we'll actually take all of them. We'll use this function twice. I like this guy because it gives us a bunch of words to be. It allows us to take the words in our no, this isn't quite what I want. Let's say similarity to, let's take the worst word in our bad words. And let's do it to the worst word that we can find. And if that is above a threshold, then we'll do this substitution. If wordvec similarity is greater than, let's just say 0.6. That's not up there. We're getting 0.7 for words like good, so that's actually probably not high enough, but we'll see. Then we can we can do our math on that word vector if it's we need to give it the word that we're trying to compare here, and then slash Venomouse slash. I got a slash missing somewhere. Thank you, Maria. We'll just see what happens. Most similar positive list of good words. We got This is going to check our word, and then we'll just print something here just to make sure that we'll print out this thing, this list, and we'll print the word itself just to see what's going on. Looks like I'm missing a close paren. So close that one, close that one, close that one. Need to close one more. Okay. I'm gonna have to do some trying. Oh, the period is not in the dictionary, so we need to do some try excepts. Now let's do except, and we'll just keep going. If we have to skip a word, and we'll be composing a sentence here just to, so new, so good, sent is going to equal, or good doc, since we're calling docs those things that contain lists. And we'll append to it later, but we'll go ahead and append the skipped words. Just like doc plus equals the word. And let's just, ooh, we don't want to reset it each time. We want to append to it each time if it finds that word. And we'll append the right word next, but for now we're just going to append. We'll use append. That's better, a better pattern than plus equals. And we can still append that string. And now let's see what we've got. Good doc, please. Oh, it didn't seem to work because you should have printed something. That's no good. What's going on? Oh, maybe we don't have any words that are, as I need to append it even when there's not a match found. And I probably need to print that similarity too. If else good doc dot append. So we're going to append the word, the same word. We're not going to change it at all at first. And let's print out something else that would be helpful to inform us of what the most similar. Let's print this line again. We'll do it in both places. Basically, we'll do the same thing, whether we find a good word or not. Oops. Dang. Let's go to foreground. Oops, I accidentally hit Control Z to go undo, but I think we're okay. We just need to go in here and let's print. We need our else statement. That's what we're missing. I can just do this without anything at all. No need. And we will just see what happens. Good. Now we'll do the filter. Now that we can see what the numbers are, we're not getting any numbers above 0.4, so we're gonna have to set that pretty low. So our similarity between bad words to our bad words. Oh. I'm not even printing out the similarity for the bad words. Let's print out the similarity for bad words. So we can just see what it's doing. So we find a good threshold. So we can detect those bad words and then change them with this most similar thing later. Good. Let's see how that goes. So we've got some similarities in the 0.26. That's, that's surprising. Let's just do one individual word, make sure I'm using that correctly. And maybe we need to say an average of some of those bad words. Let's try the second to worst word. And that didn't get any better. Maybe I should do it between a list of words. Let's call bad words. Let's go call this BW for BW in bad words, and we'll do the 10. Looks like we're going to have to take a min or an argmin or something in order to find any words that are kind of close to bad among those really horrible words. Oh, I'm taking the bad words. Looks like I might not be taking the right portion of the bad words. Let's just take the first 10 bad words. I think that's the way I ordered them. Let's see what we got here. I'm missing a parentheses, probably. No, that all looks good. Oh, list comprehension. There's a big delay between the texting and me being able to respond. Let's see, we got some, so it looks like, so the word I is not close at all to the bad words. And let's see, the word bad. Let's see, we're printing before or after. We're printing the word after the similarity. So these are the similarities to the bad words for the word bad. We're only the closest one we've got is 0.2. Let's make sure the bad words are bad. Yes, they are, but they're so horrible that it's probably struggling to find anything at all similar. So let's do every 10th, let's do 10 bad words. No, oh, we don't have that many. That's right, we already took a sample. Okay, so let's look at all the bad words. Make sure that they are there. We already are. So that's not going to help. We may have to recompose the bad words in order to get this above. But for now, let's just do that if statement. If the minimum of all, or the maximum of all this, or maybe we should look at the minimum. Maybe that'd be another way to do it. Let's see how the other ones are coming out. So the good words are pretty far away. They're close to 0. And they don't vary a whole lot. Today is far away. So you can see that today is here. And the similarities are in a list, I think right above them. Yeah, so this is the similarities. So they're all, you know, close to 0 or even negative. Bad's getting up, when the max would get us at 20. The min would have to set a threshold at like 0.1. Let's see about feeling. That one's giving us similarities also close to 0. So we could use the min or the max. Oh, there's a big one. Oh no, that's not. Oh, there's a 0.18. So that would hurt if we use minimum. So we're gonna need to use the max and set it to like 0.2 or 0.19 in order to discriminate between feeling and bad. That's surprising. Those words are. But anyway, let's. So we don't have a good algorithm set up just yet. But if this is greater than 0.195, let's say, then we can assume that's a bad word. And Let's see if I can hide the window so I can only see the chat. I wish I could break out the chat separately. Nah. Okay. We've got, so it's greater than 0.195. We're going to, else we're going to still good doc.append. And then the next thing we're going to do is we're going to perturb that word. So we're going to good doc. Instead of appending the bad word that we found, we're going to append something different. We're going to print them. Let's see if we can figure out from that list. After we printed out bad, these were the words that we changed into, was joy and joyful. So the first one looks pretty good. Let's just use that one. And we will just take the first. So we're going to say good doc.append. But we're going to only append one word, not that whole list of words. So we take the first one in the list, and we take the first element of the tuple, because we don't care about the score. And let's see what we accomplished here. Oops, missing another close parentheses again. So good doc.append. Did I close? Which one did I close there? So I closed that one, and I closed most similar. Ooh, I did the append close too early. Great. Now let's see what we've got. I'm probably printing out the word. Ooh, I'm printing out some bad words that aren't bad. That's not so good. So we may actually change more of the sentence than we wanted. But let's just see what the good doc contains. Joy, joy, feeling joy today. Okay, that's not so good. We got to do some more work. We got to first. We got to do a better job of not pulling out I and associating that with bad words. And then the other thing we got to do is we might need to perhaps look for emotion words, or perhaps even we could just look for words that are in our lexicon. If they're in that lexicon, we could just make our bad words list a lot bigger from the sentiment analyzer. That might be a stronger way. An apostrophe M. Those are coming up as bad words. Wonder why that is. Let's see what those similarities are. Let's make sure we print out that. First let's compute the max similarity. Max badness. Just make sure there's not some simple fix for this. If max badness. We'll go ahead and print it out. And this be a little more helpful with our print statements. Anybody who's familiar with Python 3 will love this feature. You can just take your variable and put it right in your string, as long as you make it an F string, format string. And I should do that here. Bad word. We can just append that. No need to be fancy there. Let's see what we got. So we do have, bad's only 0.2 and max, and let's try min badness just for yucks. Though I know we had a pretty close score on one of the other words. I think it was, I don't remember what it was, but 0.1, let's just try 1. Oops, did I do that correctly? Yeah, I did. So still getting I and IM, but those have feeling bad. They're all getting the same. Ooh, okay. I'm printing out the wrong thing. Because they were all the same. Let's see, and let's change the explanation just so I'm not getting confused. We've got min badness is 0.1, so that's going to give us, for the word we're actually trying to target, the bad word, the min badness is 0.2, but we still have a min badness that's pretty high for I and I'm. No good. No good at all, unless I'm doing something wrong. Okay, we're gonna have to come up with another approach to detecting the bad word. So let's just detect bad words. We should probably make this a function so we could constantly be changing it. But for now, let's do that. Is bad word. That way we can put this try except. We're gonna put all of this in a def is bad word v1. We take the word and we see how bad it is. We'll go back to the max badness approach. Oh, looks like I was still doing max. That's why things weren't working. Somebody probably caught that. I'm gonna go back. I'm gonna go ahead and modularize it first. And then we'll come back to this and fix it up. Good doc, append. Most similar to positive list. We don't want to do all of this. We're just gonna let the return true. And then the rest of this can go away. And we'll just pass here. And then we'll turn false. Need to change that to 0.2 or 0.19. And we'll go ahead and do 0.2. And then we'll go back to that min badness approach and see if that works. Is bad word I'm or I. Def is bad word v1. Oh, maybe something's bad. Okay, we're not doing anything. Max, listen. Try if max badness greater than. Huh. Oh, because I'm not using the word. I'm using the old one. Let's keep that back up to 0.2. Now let's test our function. True. This should be true as well. And this should be true as well. And then we should get a false for feeling, I think it was. And we should get it for the period as well. Good. Okay. We should put those as doc tests. Let's do history-o-p. And we will put these as doc tests in our function. And we'll actually put it in a script. Anybody familiar with this? You'll love this little trick. You can create a bunch of doc tests, so I don't have to keep typing those all the time. I can just run doc test mod on this module once I create it. Because ultimately, I think this will be a good tool for query to have, to be able to detect bad words and replace them. So we're going to incorporate this into the successor to NLPIA bot, which is called Query, Q-A-R-Y, on GitLab at tangibleai/query, open source, of course. And we're going to be putting these functions there. So now we're going to say hist on that, grab that, put it into the actual dflame module. Let's do some imports. Oh, we need to share, I need to share my Sublime world. Switch over to, oops, not that one. Let's turn off console. And no, we don't need LibreOffice. We don't need browser. We need Sublime. There we go. Okay, so I'm just putting it into a file. That's all I'm doing. Should get us close. What's it complaining about? Long lines, bad words. Oh, we need to create our lexicon. Let's find out how we create bad words. Bad words equals, there we go. So we're gonna have to go and get that lexicon. Copy. Have to do the import there. I won't try to waste your time doing all this, but this will remind me what I need to do in the future. Let's go back to the console so you can, let's go turn off Sublime, go back to console. Now we're in business again. Okay. So what we've done is we created a function that can detect bad words, but it doesn't work because we're going to modify that and create a new version of it. Let's do that actual modification in Sublime so I can edit it more easily. Even though we don't have everything working there. So let's turn Sublime back on. There we go. Now you can see what I'm working on. We're just going to duplicate this V1. We'll make it V2. We could put that, we actually don't want these to return. We want to make our test case actually pass for the stuff that we want it to pass on. And so, and this is V2 that we're working on. Okay. And now let's see if we can just find it in our bad words lexicon. If we don't need this anymore, if word in bad words return true, then we're good to go. Prints are a bad idea. Let's not do that. Well, and we'll put this inside of once we Okay. We could return false here too, but that's not necessary. Okay, so far so good. We just haven't changed much except this bad words thing. So we're going to need to make sure that bad words contains a lot of bad words. Now let's go back to the sentiment analyzer lexicon. So say lexicon is what we first equals. SA lexicon sort values. Great. Now let's get all of the bad words. Let's look at the various locations in that lexicon and see when do the words get bad. When do they transition to reasonable positive values? I can just do a query since this is a series. So I'll say lexicon greater than. This is not actually just the words, it contains the scores. So we look for negative or less than, lexicon less than. This is a nice pandas trick. We're going to say less than point negative. What were some of the scores we were seeing before? I don't remember, but let's just try -1 and see what we get. Yeah, okay, so we got some very bad ones. Let's say less than the ones at the top. Let's look at only the marginal words, just to make sure we got moodier cut. Are those words we want to get rid of? Probably. Those don't look too great. Let's go a little lower, a little higher. Viciousness, yeah, that's another bad word. Kildes. Boreal. Now that's not too bad. Fomen, not too bad. Petrifications, petrifying, not too bad. So about 0.4, 0.5, we're probably pretty good. Ineffective, that sounds pretty bad. Bitters, numbfish, cautious, those aren't too bad. We'll stick with 0.4, and that'll be our bad words lexicon. Am I looking at the worst of them? Yeah, I guess I am. So now we're going to say bad words equals. Now let's define our V2. I'm just going to paste it over from that one we just created in Sublime. Now we're good to go. Okay, and is bad word V2. Let's do that doc test. Oh no, I can't because it's not defined as a module. I don't know how to do it on a function, so we'll just copy and paste those doc tests and just run them all at once. But I can't do that either very easily. So let's just is bad word V2. Let's talk about bad first. Good. What about I? No. Good. What about him? Good. Now we're getting somewhere. And let's look at anything else we've got in there. I can't remember any other the words in that sentence, so let's just use it. So now let's go back to our translator, our deflamer. Let's create a function for that. Let's find out where we did this before. So I did a try except in the loop as I was going through that. So I think it'd probably be the latest one where I used try. Come on, there it is. So this is the thing I need to turn into another function. We're going to call this deflame. And we're going to give it a string. Let's call it text. Because stir starts out. Let's see if I can use tab. Yes, I can. And I can probably use it. Oh, no, I can't. Darn. Okay, now we want to do is bad word. This is bad practice to have that global variable define the behavior of this, but ultimately all this will be in a class where those bad words are defined. Is bad word, you can think of this module as being sort of a poor man's class. V2, and the word we're passing in is W. We don't need min badness anymore. Let's be careful about getting rid of that. Next. Wow, this might work. Deflame. I'm feeling bad today. Oh, that inflammatory exclamation part might get changed. Oh, it didn't return anything because we made a function and didn't return the good doc. Probably missing got one too many spaces. Good. Try it again. Excellent. Let's detokenize the text. There's a detokenize option in Spacey, which I love. But for this one, we're just going to have to assume that there was a space there, even when there wasn't. Join. There we go. And in LP in action, natural language processing in action, you'll see how to do all this tokenization properly. We're doing it the quick and dirty way here. But as you can see, ooh, it didn't replace the word. Found a bad word. Bad word is bad. Okay, so far so good. Oh, because the most similar one is the word bad itself. So instead of taking the, I should print out the list of possible words. In fact, I will do that. Let's be a little more modular about this. First, I'm probably going to use that second word in the list anyway, but let's do something interesting. So this is the good replacement, and that's going to equal, or we could call it replacements, and we'll take them all. And to do that without the score, we're going to do it like this. Oh, we can't use W. That was a stupid variable name. Let's try good word for good word and then we're going to call it good word comma score. That should give us a list of good words, and we will put them in square bracket. Oops. What did I do there? I can't undo very easily. Let's see. I can't hit Control Z, that's for sure. Control Shift Z? No. Let's not do that again. Let's try just retyping it. Good word, score. And word vector was similar. Good words, negative, list, bad words. Maybe this will not have any syntax errors. Let's try what's going on. Oh, I haven't replaced anything or done it or printed anything. But let's replace, let's do a good doc append. I'm going to append a really weird string here. I'm going to append a list of strings. You put these in square brackets in an actual document when you're trying to edit a document to give people let people know that you're kind of suggesting some words, or what's called the SIC notation, SIC. We can add it as an actual variable, and it will have that nice. That's what I love about Python. It's English language friendly. It's readable by people who know English. As it actually complies with a lot of punctuation and syntax rules that we have in English. So I think this will give us a bunch of options for the good replacements. Probably should limit it a little bit. Let's do it to only, oh, it has 10 already, so 10 words, but let's limit it to 5 just so we don't get confused. And let's start, we know the first one's bad, so let's not start there. So we'll have 4 words that might deflame this text. I'm feeling bad today is still there. Let's make sure is bad. Perhaps I didn't redefine is bad word. Let's make sure is bad word is still working. Try is bad word, word to vec word. I need to, whenever I have an accept, I need to print that out for sure. Exception. Because I could have all sorts of syntax errors in there. It did have an exception. Interesting. So we need to print out a little bit more than that. Let's accept E. And then let's print out the error. Deflame. Huh, I thought there was a way. Oh. Rookie mistake. Exception. I could also just raise it. That's probably the better, easiest way to do it. Cannot unpack non-iterable float object. Most similar. Okay, let's see what we've got. So this is probably happening in here. Let's break this down. Let's just print that bad boy out. Oh, that's what I already did. Keep hitting that Control Z. It's a bad habit. Let's. I'm already printing that thing out. Let's see what else we can do. Let's just run that code all by itself and see what's in there and make sure I'm using it correctly. Oh, this is that word not in vocabulary problem. Oh, so that's why we're doing the try. And let's just use that key error as our only exception that we catch, and let's let everything else pop out. That's good. I don't need to do that anymore. next thing I need, now let's go ahead and get that saved. But next thing I want to do is check out that that command that I just did. So most similar. So word2vec, good words, list good words plus the bad word that we're trying to work with. Negative list of bad words. Oh, we've got a huge list of bad words. Not a good idea. We need to say short list bad words, or some bad words. Let's call it that. Or 10 bad words. How about that? We can't use 10 at the beginning of a variable anyway. Could have spelled it 10, but we'll just do it this way. Bad words 10 equals bad words. Let's get a broader sampling. Let's start with negative. Ooh, I wonder how long these are already. Bad words. Let's start at negative 1,000. 1,000 from the end. So bad words 10, negative 1,000, colon, and we're going to end at the end, and we're going to skip every 100 words perhaps to give us 10 words. Bad words. And we need to, it looks like I forgot to take out the scores from those bad words and didn't do dot index on that series. Let's see what bad words is. I think it's a series. Yeah, so that's what's going on. I was expecting words and I was getting floating point values and all sorts of weird stuff. But now I think we're okay if I just say dot index dot values, and then we should be okay. And I'll need to do the same in my if statement probably. No, I think that was working before. Let's make is bad word v2. Anybody talking to me? Good replacements. Ah, thanks, Maria. I might be using a variable that doesn't exist in that function. But let's see if get bad words going to work for me at all. Make sure bad works. Make sure feeling doesn't work. Great. Okay, so that's the problem is in my master function here. And good replacements equals good replacements, good replacements. That's all good. We're not doing any replacement. And let's just grab the first or the second one. Let's grab the first one. Thank you, Maria. Oh, try is bad word. Oh, no, we don't want to do it in the else. Oh, I'm appending it here. I'm appending it as, that's not what I want to do. So I need to undo what that just was. I just want to append the actual word. When the word is not bad, and we can say it was because no exception, no key error. We just want to append the, and let's just do the same way here, just so we're in the same world. Still something wrong with this along the lines of this bad words 10. And it's a series, so let's say dot index, and let's say dot values. I bet I could take off the values and everything would work fast. And I don't even have to say list, I don't think. Better, just in case. I think this is going to be work a little better. But it's not going through good word score, it's just going through good word. Yeah, it couldn't unpack the float. If I'd paid attention to that error message, that would have made sense. This GW comma score, that can't map to a single floating point value, which is what when you iterate through a series, that's what you get. You get the values, you don't get the index. So it's not like zipping a dictionary key value pair. This should be a little better. I think we found the problem. Now let's look for our deflame. Quote. Great. So we can choose any of those words, and let's just choose the first one. I'm feeling luckiest today, or happiness today. Ooh, that's going to be a hard one. Should probably find the one of them that's closest to the other word, and that would give us a motion word. We can work on that later. For now, we'll just take the first one like I was going to do before. And we will just append only the very first. Oh, but it's not the very first one. It's the second one in the list. I think we're good to go, finally. I'm feeling luckiest. Oh, we appended both things. Good replacements. Because, why is that? Somehow, oh, because most similar is also returning a tuple, not only the bad words thing. So I do need the score. I think a friend is bringing me a burrito. So I better check my messages. No. Good. I'm feeling luckiest today. Okay, well, we deflamed at least one sentence. Now let's see how poorly it works on something a little more creative. Could somebody give me another phrase that contains words that we could deflame? Let's say so-and-so is a horrible person and I am the best. I think we've heard politicians in the US say this. So bad corpus, we'll call this. And we can add our other one to it later. And then we'll just go for bad. We'll have to make sure it's splittable. I'll need to make, and so I don't have to import. For doc, for text in bad corpus. Deflame text. And let's print that out, and then we'll get rid of the other print statements, and then we'll have a nice clean corpus. Probably want to print the bad text first, and then we will print some sort of a separator. No. Deflame seems to only remember one phrase. What's going on here? Did I get text and bad corpus? Maybe I'm not deflaming the actual text. Where am I getting the words from? This is interesting. For W and doc. Got it. Text, we need a doc equals text.split. That wasn't so good. Now we're good to go. corpus. So-and-so is a elation person, and I am the best. Wow. We can at least, we can't produce grammatically correct sentences, but we can at least neuter them and make them less horrible, deflame them, defang and deflame them. Let's see if anybody's come up with why successful people are, oh, wow. Maria, we will use that one. Add that to our corpus. Oh, I'm not scrolling. Oh, let's add that to our corpus. I'm not feeling well today. That's not gonna, that should pass through without any problem. And now let's add Maria's Venomouse. We've got a lot of capital words in there. Looks like you found that on somebody's tweet or somewhere as a title. Weird. The link for your book on the Twitch page is a bit mangled. Oh, okay. Thank you, Art Splunge. Try to fix that. Where are we now? Let's see. We're at 5:30. Wow. So we started at 4. We got another 30 minutes. Let's see what we can do with this corpus. See how Maria's. So-and-so is a horrible person, and I am the best. Oh, why successful people? Ooh, it didn't find douchebags. Okay. Douchebags is not in our, oh, because we need to lower it in order to find it in that list of bad words. Because I happen to know that the lexicon has been case folded. If you read the book, you would know that case folding, either lower cases or upper cases, all your words, so you don't have to have copies of them and all the different capitalizations in your lexicon. So let's do that to the words that we're checking for. Where's that in statement? Oh, it's in the is bad word function. So let's do that. Let's look for the is bad word. Def is, there we go. And we need to lower it. Let's make sure it's a string first, and just in case somebody passes us a number. And then we're going to lower it. We're going to strip it too, just in case they weren't already stripped. That should make it a little more likely to find douchebags in the bad words. Even though Vader was written back in the 60s when they didn't have nearly as inflammatory stuff going on, hopefully it'll still be there. Now, corpus, there we go. Oops. Still no joy. Let's make sure it works on. Let's make sure it still works on bad. Whenever you always want to check for regression errors. Today and yesterday, I was great. It didn't even do horrible. Oh, it did find horrible. But we need to, why successful people are douchebags. Maybe, I don't know, maybe a hyphen. Well, I'll check the lexicon. We'll have to come up with a better way of finding bad words than using this lexicon and similarity to that lexicon. Maybe we can just add our own more words to a lexicon of bad words and look for word-to-vec similarity. Word-to-vec similarities can help generalize from new words. Let's just see if it's similar. Let's make sure this works again. Yesterday. Changed it bad to luckiest and changed horrible to elation. But douchebags we're having trouble with. Let's see if we can do some investigation into douchebags. Let's see if douchebags is even in word-to-vec. Great, we're good there. So let's check for word vector similarity. I think we can take, and let's say bad. Not very similar to bad. Horrible. Get a little better. Jerks, maybe? Yeah, we're gonna have to add some. And it's gonna have, it can be pretty far away because the meaning of that can sometimes be a little bit mild, I guess. To catch those on the edge that can be kind of joking and mildly negative, we may have to add some word to our corpus. And bad. Maybe taking out person from words. Let's do some fancy analogy work on it to see if we can take out person from any words that are close to person and then add the goodness to those words. Oh, we can use that. We can use the word similarity math if I don't want to have to show you how to, well, I guess this is as good a time as any to show you how to do math on word vectors. So this would be a non-person, non-bad person, a non-person who's bad. And but this is the vector for that. Let's make sure and we'll, or maybe we could take out the badness and see what the remaining meaning is and then add back the, and then add goodness to it. We'll do it the actual word-to-vec way, I mean the analogy way. We need to divide by, actually, the way that I saw they did it in GenSimp is they actually do it, they do the division by 2 separately before they do the multiplication by the vector in order to get the average. And then we need to take and we divide it by the norm of that vector. So we say, let me see if that's my friend. Yes, it is. He's having trouble ordering a fish and chips burrito. They don't sell them at a lot of places. But that's what I'm hoping to get to refuel me after this session. Non-person who's bad vector. Okay, so we got the vector, but we need to normalize that vector. Let's so non-person, we divided equals np.linalg.norm. Oh, we can't do the divide. We need to do the math the way GenSim does. I found that this does actually change because it's a 300 dimensional vector. Times. So you do times equals. That's what I need to do. Do the division separately. I'm not sure why this makes any difference, and it may not. Somebody can text me if they want to try it with the direct division way. But first, I'm going to say so NP times 1 or I'll just say 1 dot divided by np.linalg.norm non-person who's bad. There we go. Times equals. Now we should be good to go with a vector that we want to find most similar. So word vector, similar by vector, non-person. And what I didn't make this a non-person anymore. I think what I did was I just subtracted bad. So this is a non-bad vector. Looks like Burlesque Troupe, Coffee Mugs, and Vandelay Industries. And bag giveaway. Let's see if anybody else has anything less crazy to work on. She's a lying, manipulative, narcissistic woman. Oh, Maria's come up with a replacement for her bad one in our corpus. Hopefully these will appear, and let's append that to our corpus. Bad corpus plus equals, and let's make sure we tokenize it for ourselves manually, so our simple tokenizer won't barf. What I want is, let's look at the bad corpus looks like. Excellent. Now we need to do the deflaming on each one of them. I guess it was deflame text. That's the one. She is, oh wow, it really likes that word elation. She is an elation, manipulative, narcissistic. Oh, it didn't catch narcissistic or manipulative. Okay, so these words about people aren't showing up in the corpus of bad words we've got. So we got to have some way of dealing with these. Maybe we need to translate them to non-person words before we check for badness, which is what I was working on with this word2vec thing. Let's look for that. Where was that? I need to, when I was thinking about subtracting person from it, that might be the path to go. But let's finish this one up. No, we already did that, and we found that that gave us sort of proper nouns that were people, because that that word was douchebags is kind of a person word and it's capitalized. So it gave us capitalized words in return that were not as bad, but not necessarily much better than douchebags. Let's think about like Vandelay Industries from a nice, oh gosh, Chevy Chase, a good Chevy Chase movie. Let's talk about non-person who's bad. What are we going to do? We're going to try to subtract person. Let's try to subtract person from some of these words and see if any of those are in our bad words dictionary. Let's say person. Oh no, we don't want that. That's not going to help us. What we're looking for is we need to get the vector math. Who's bad vector? We need to do this. Let's do this. Let's put that in a function. Def. Add, and we'll take a word, and we will that way we can add so this is base word modifier And then we'll do that stuff that we were doing earlier. First, be careful if we make multiple modifiers, we'll have to base word, let's say new word, new vact, we'll call it vector, equals 1/2. Change that to base word. Gonna need a try except on that. And modifier, and we'll need to add instead of subtract. And then we'll need to normalize. Times equals 1 divided by np.linalg.norm. This is just the Euclidean norm, that Pythagorean theorem that you're so familiar with, and we need to do that on the vector to normalize it so it has a length of 1, and then we need to find the most similar word. How did we do that? Similar by vector. And we can output just a few of those. We'll just output them all for now, including the scores. And let's just see how that works. That way we can try a bunch of different things. Let's make those allowed to be strings, so we don't have to. So base word equals word vector base word. Thank you for your attempt to make it easy on me, Maria, but it's just not possible. Modifier equals word vect. Modifier. Now let's see if we can add. Let's try. What was the one we're trying to? Manipulative. Oh, we don't have a way to subtract. So we're going to need to add another argument. I wonder if there's a... Let's just do a weight. That way we can add as much or as little of it as we want. And we'll set it to 1 by default. And so we do that by weight. And in the future, I'll take a list of words and we'll do the proper average of those. Next, let's see if we can do that add again. Well, I didn't actually try to run it because it wasn't going to work. Add to narcissistic. Let's add or subtract from that person. Let's just see what in the world we get out. See if this idea is going to work at all. I didn't spell it right. I'm sure Maria did. Double S. Narcissistic, maybe? Okay, got something going on. Base word modifier, 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 base word modifier. I don't see it. Oh, silly. I'm changing them to words here. Did it twice. Somebody, I'm sure somebody pointed that out. 21 reasons to hate kids. Oh, that's a bad one. We'll add that to the corpus for sure. Bolton Trump is a moron and a criminal. Oh, I don't know if I want to deflame that one, but I will be happy to for you. Weird. I was just don't see anybody else interacting, at least on the Manning chat. I'm not paying attention to the other chat over on. Doesn't look like anybody's. Oh, I'm on the wrong channel over on Discord. Let's see, where's Manning's? Some reason it sent me to the Rust conference for Manning, but anyway, whatever. Manning Publications General. I don't see anybody. I don't see any channels associated with this one. I must not have. Maybe it's the data science one. Anyway, won't worry about Discord. I'm stuck on the Twitch chat. So let's add return word vector similar by vector. What are we doing here? Oh, I fixed up that misuse of the double word vector lookup. Now let's try deflame, and then we'll add some more sentences. Corpus, and let's add a couple more sentences from Maria. 21 Lessons is one of my favorite books of this of 20. I guess it came out in 2019. Yuval Harari shows us what to be wary of in this 21st century. 21 Lessons of the 21st Century, if you're interested. What was the other one she mentioned? Bolton and Trump. Let's grab that one too. I'll need to punctuate them with our tokenizer spaces, or delimit them, I should say. That one looks okay. This one needs a slight modification. Oops, bad corpus. Now, go back and see what we've got. What do we have? We've got, works okay on our null case, works okay on our bad case, obvious case. Let's get rid of the print statement so it'll be a little easier to play with here. Narcissistic, still not working. Oh, of course, we didn't try. We're not using add yet, but let's try to add narcissistic quoted to, we're going to add negative the person, just to see what's left over when you take the person out of narcissistic. Self-absorbed, egocentric, narcissism, not so surprising. But let's see what happens if we add to that person something good. I'll need to modify it to take lists, because I'm sure this, I'll just use the most similar one that GenSim has in it, because this isn't going to do much good. I'm not sure. I'm pretty sure. Oh, that's no good, because we're returning we're returning multiple words. So we need to, in that function, we need to return a single word if we just want to use that one word. Burrito is on its way. Nice. Let's return just the word, and let's not return the first one. Let's return the second one. See if that add works a little better. Egotistical? Interesting. But I bet that's similar. I bet it would just tell me that for if I did most similar on narcissistic. Because that's probably a word that's already close to good. Didn't seem to change it much. Probably need maybe add back person or something. Anyway, let's see what we've got here. What was I doing? I want to see. I want to do the most similar. Or similar by vector, similar by word. That's what I'll use. Word vector, similar by word. Let's do narcissistic. Yeah, egotistical's right there on the top of the list. So we didn't do much by adding good to it. That's interesting. Let's add some other words. See if we can push it a little harder. Ooh, just went right back to narcissism. What about generous? Maybe. Oh, if you add generous, that takes over. What about humble? Yeah, looks like once you take out person, it's not really, the adding is not really doing much for us. But let's talk about, let's do something different. Okay. We were going to add those word vectors. Let's use the most similar function within word2vec that's designed to do this math. Make sure that I'm doing it reasonably well. We'll do positive equals narcissistic. And then we'll do, let's go ahead and make that a list. And let's just do the math exactly the same way that I did it. Negative equals person. Finally, we need to add humble. Let's not do humble though. Let's do the first one we did. Well, none of those really came up with anything useful, but let's just try good. Interesting. Egotistical is still on their list, but it's not at the top of the list. I think that egotistical is the one we came up with our math. Bad and great are there. Great would be a nice replacement for narcissistic. Clearly, this algorithm needs a lot more work before we're going to be able to deploy it to query and help people find some good replacements for bad words. But we're on the right track, I think. We could use word2vec. We're going to wrap it up here. I'm getting hungry, and my burrito should be here shortly. Let's see what it did to 21 reasons to hate kids. Did it get rid of hate at all? Elation. It really likes elation. We've got something going on in our code that is only finding words that are in that lexicon of Vader's negative words, and it's only and it's not doing a super good job of replacing them with anything that's of the same part of speech. So there's some really cool stuff in Spacey. I'll just close out with a little bit of Spacey. Maybe I can delete the word2vec model from memory so that it will not overwhelm me this time. Del word vector, and let's double check our RAM. Oh, 10 gigabytes already. It's probably not going to free up much. I should probably just exit and start over. I'll record all this and put it up on gitlab.com/tangibleai/query, QARY. There'll be a file in the ETL directory called dflame, and that's where I'll put all this work. If you'd like to help us out, check it out, and would love to see you there. We have a lot of contributors that we meet every Wednesday night. So if you want to, if you're serious about helping us save the world, we can you can join us on Wednesday nights. And that's about it. Thank you all for signing in and joining me here. Looks like we didn't have a whole lot of visitors, but it was good to see those of you that were here. Thank you so much. Thank you, Maria, for saving that link. I guess I should also put the link up to the book, and also the GitHub link to the NLPIA repository. Actually, I think it might be in Total Good / yeah, I did put it in Total Good / NLPIA, but I'll put, I think it was NLPIA bot that I had over on the NLPIA section. Anyway, if you want to see how to install the source code for NLPA, Natural Language Processing in Action, that's where to go. And the link that Maria shared with Query, that's where the bot itself, NLPIA bot, has evolved. That's a bot that can answer questions. I'll give a demo of that now that we're over time, and now that I can do the stuff that I really enjoy doing. So let's launch Query. Let's ask her what narcissism is and what a nice alternative to narcissism is, and see if she can help us out. She goes out to Wikipedia and grabs and tries to answer natural language questions using BERT, a pretty cool transformer. Albert actually is the one that we use here. Let's say, so what is a nicer word than narcissistic? Still can't spell it. Narcissistic. I'm pretty sure she is not going to do very well on that question. She doesn't usually do well on, she does well on who and when and where questions, those that can usually be answered towards the yeah, she didn't do that one. Let's try who is the most narcissistic president of the United States. She only checks one Wikipedia page, so if you don't happen to include some good words in your query that include Wikipedia articles that she can find with an answer to this question, I'll try less inflammatory questions in a moment. Oh, you're not even able to see my bottom line in my... Oh, that's bad. I need to do a better job of scrolling up so you can see. I'm cutting off the bottom. Let's not do that in the next session that I hold. Let's do the console. Let's see if I can turn off Sublime. Okay, let's just try the good old question. Who is the president of the US? Okay, let's go back to a regression problem. When was Barack Obama born? Thank you all. If it doesn't get this one right, I'm going to give up. I may be on the wrong branch. Maybe that's the issue. One query. It's definitely a work in progress. At least it found the right Wikipedia article. Okay, great. At least it's not completely broken. I was just asking some tough questions. How many? This one it had trouble with recently, but one time it got it right. Are there universe? I don't think I want to capitalize universe. I'm just having fun here. See y'all. Can I try capitalizing and abbreviating the sentence maybe? Okay, found a page called, oh, maybe I'm misspelling galaxies. Huh. It did this well last night, but not tonight. Probably should include the word brain. Yep, that's not right. I think 302 is the number of neurons in a worm that is commonly studied, with the smallest number of neurons in an actual brain that can be studied and genetically sequenced. It's one of the few it was one of the first brain maps that Paul Allen's group at the Brain Institute actually were able to simulate with any significant fidelity. That may be correct. Let's see if we can word many neurons in a human brain. Well, it's going. I'm going to check Wikipedia. Looking forward to building a challenge bot to see if a human can go out on the web and find answers that are any better than Drosophila is the fruit fly, and the connectome might be yeah, it was going to list approximately 135,000 neurons in the brain of a fruit fly. And yes, 10 to 20 billion, I think that might be correct for a human. Let's look and see that one up as well. Anyway, it was fun. Thank you for hanging on despite all of the fun we had. Good night.